Our next lesson is on literal equations and formulas. So a lot of what we do in Algebra 1 and your future algebra and mathematics courses deals with multiple variables. And equations that have multiple variables are called literal equations. I don't really use that term often, but that is what they're called. So in the resources from the bin, or if you download it online, is what's called a Freire model definition. In a Freire model, there are 4 sections. There's the actual term, literal equation, and then there's a definition, some facts and characteristics, examples, and non-examples. So let's look at the Freire model for literal equations. A literal equation is an equation that has 2 or more variables. So a lot of times you'll see that in formulas, like, for example, x plus y equals 4. That's a literal equation because it has 2 variables. Or the formula for volume of a rectangular prism is V equals LWH, which is length, width, and height. So this one here is all variables. Or it could simply be y equals 3x plus 4. Now some facts and characteristics, they must be different variables. So if it's just like x plus x plus x plus x plus x equals 3, that's not a literal equation because the only variable there is really x. It just shows up multiple times. Second, always has to have an equal sign because it's an equation. And next, it could be all variables. So we saw a case where it was all variables. Here's a case where there's no equal sign, so that would be a non-example. This one here has an equal sign, but it's only got one variable, which is y. And on this one, there's no equal sign and there's only one variable. So these both are called expressions. Okay, so that's the definition of literal equation. We're going to use and manipulate literal equations now. So when we're working with equations, it's all about manipulating the variables and the numbers to get it the way we want it to look. Well, let's take a look at this example. You should pause the video so you can write this down, and you can underline y and sandwiches in red or whatever color you wish to use. I'm going to use red for most of this video. And let's take a look through the problem. So example 1, the equation 10x plus 5y equals 80 models the number of pizzas, x, and sandwiches, y, you buy. How many sandwiches can you buy if you get 3 pizzas? And what about 5 pizzas? So now we're going to go through the process of solving this problem, but in a different way than you've solved it before. We're going to take a look at this equation. I know x is the number of pizzas, and y is the number of sandwiches. And in this problem, I'm trying to figure out how many sandwiches I can buy if I get a certain amount of pizzas. So I'm going to manipulate this equation so that it's y, or the number of sandwiches, equals something to do with this 10x and this 80 and the fact that x is it represents the number of pizzas. Okay, so we're going to go through that process. The first step is going to be to write down the equation, but in color, I want you to put the variable that you're solving for. So in this case, because we're trying to find the number of sandwiches, which is y, we're trying to solve for y. So we're going to put y in red. Now, in order to get y by itself, we're going to treat everything else like its own term or its own kind of number. Just like solving an equation for x, we're trying to get everything away from it. And we work from the outside in. So on the same side as this 10x is, as this 5y is the 10x. So my first step is going to be to subtract 10x from both sides. I want to subtract 10x from both sides. Notice how I put the 10x over here because I'm not taking it away from 80. Right, it's not 80 minus 10 giving me 70. Those are two different things. In doing that, I now have 5y equals 80 minus 10x. Lastly, y is not by itself yet. It has a 5 on it. So I want to get rid of the 5, which means I'm going to divide everything by 5. In order for it to be balanced, when I divide by a number on one side, I have to do it to every single term that's there. To this term, and to that term. If you don't do that, then the equation isn't balanced, and you're not going to get the right answer. So after dividing everything by 5, we're left with y equals 16 minus 2x. Now you'll be asking, well, what does that really tell us? So this makes it easier to figure out the number of sandwiches based on the number of pizzas. And that's what we're going to do right now. So I'm trying to solve for when I have 3 pizzas and when I have 5 pizzas. Now in the problem, x represents the number of pizzas. So I'm solving when x is 3 and when x is 5. So all I'm doing to do that is putting in or substituting 3 for the x. Notice how this is y equals 16 minus 2x. But now x is 3. And I go through the process. 2 times 3 is 6. 16 minus 6 is 10. And I do the same thing for 5. 16 minus 10, which is then 6. So my final answer is that I can get 10 sandwiches, and then I can get 6 sandwiches. So that's the solution for example 1. On your left side, you're going to do this problem here. What if the equation in example 1 was 4x plus 10y equals 60? You're going to redo the problem again for 3 pizzas and again for 5 pizzas. Okay, so you're repeating example 1 but with a new equation. So once you turn to a new page and retitle this, we're going to do example 2, which is solve the equation 4 equals 2m minus 5n for m. Then what are the values of m when n equals -2, 0, and +2? So this is a typical question that you'll see on a test where you're given a literal equation, right, that has 2 variables in an equation. You're asked to solve for the variable first and then solve for the variable when n are specific values. So that's what we're going to do. We're going to do the solution for that one. So again, I'm solving for m, so I want to put m in its own color. I used red. And just like solving any equation, I'm doing those properties of equality to get the m by itself. So I would add 5n to both sides, and I'd be left with 5n plus 4 equals 2m. And then I would divide both sides by 2, which would leave me with 5n plus 4 all over 2 equals m. And you can also write that as 2.5n plus 2 equals m. Right? So it might look a little more cleaner on the right side. But if you have a nasty fraction, like that ends up being 3.6666666, and you should probably just leave it as a fraction. So we did that very first step. We solved for m. But now we have to go down, right? And we have to evaluate when n equals 0. I'm sorry, when n equals -2, n equals 0, and then when n equals 2. So we are evaluating 3 different times using our new equation. So for n equals -2, I would have 2.5 and now times negative 2 plus 2 equals m. 2.5 times negative 2 is negative 5. When I add 2, I get negative 3. So negative 3 is equal to m. Now I do it when n equals 0. Again, my equation is 2.5 times n, which is 0 in this case, plus 2 equals m. 2.5 times 0 is 0, plus 2 is just 2. So 2 equals m. And lastly, I'm evaluating when n equals 2. So that's 2.5 times n, which is 2, plus 2 equals m. 2.5 times 2 is 5, plus 2 is 7. So 7 equals m. So there are my 3 solutions. Next up is example 3. Our last problem, what is the radius of a circle with circumference 64 feet? Round to the nearest tenth and use 3.14 for pi. So we're going to do this a little bit differently. We're going to start with the equation circumference equals 2 pi r. And I know I'm trying to find the radius, so I'm going to redo that, but the radius is going to be in red. And I want to manipulate this formula now, right, because it's a formula, not an equation. I want to manipulate it so that the r is by itself. So I'm going to divide both sides by 2 pi. And by dividing by 2 pi, that cancels out in both places. So my formula becomes circumference over 2 pi equals r. And my very last step is to substitute 64 in for c, because I know that their circumference was 64. So that's 64 divided by 2 pi equals r. 64 divided by 2, and if we use 3.14 for pi, then the answer is 10.2. So the radius is 10.2 feet. And that's it for the examples for literal equations. On the left side of this page, I want you to do the following 2 problems. Solve negative 2x plus 5y equals 12 for y. And then as a challenge, try and solve ax minus bx equals c for x. This is a big challenge problem. I want to see if anyone gets this one. And let your teacher know once you have the answer. And you'll be ready to move on to the practice from the textbook.